Hello, chemistry student. Today we'll be talking about 12.2. So what does the word polar mean? Polar, like our planet is polar, does that mean that all the sides of the planet are the exact same? And the answer is no. So polar means uneven. So the North Pole and the South Pole are not the same. One is mostly water, North Pole, and the South Pole is actually solid land covered with ice, but it's still solid land. So a polar molecule, for example, if I have carbon monoxide, if I cut that in half, the left and the right side are not the same. If I have carbon dioxide, however, that is not a polar molecule, because if I slice it in half, the left and the right side are the same. And if I slice it this way in half, it is also the same. Okay, so if there's any differences, whether left or right or up and down, it is polar. And if it's even in every way, it is non-polar. So there are forces in between molecule and forces inside a molecule. My interaction with someone is what I'm doing between me and that other person. Whereas the word intra means inside, right? So I guess commonly it's really hard to think of another intra, but a word similar to intra is intrinsic, like inside, related to my feeling and what motivates me. So INTER, enter, is mean in between, and intra or entry usually means inside. Okay, so the interaction between two molecules, like a carbon dioxide and a nitrogen, that's intermolecular forces. And intramolecular forces is like the forces within one water molecule between the hydrogen and the oxygen inside water molecule. So which one do you think is stronger? I often say this, think of two pieces of tape. Each one of them is a different type of molecule. So say a piece of duct tape and a masking tape. And if I tape them together, if I pull it apart, most of the time the tape still hold together. So the forces in between them is the stickiness between the two tape. And the intramolecular forces are the forces that hold that one individual piece of tape together as a self. Okay, so intermolecular forces, the two pieces of tape being sticky together, versus the intramolecular forces, which is the forces inside that piece of tape itself that hold that piece of tape together. Which one do you think is stronger? Okay, so once again, inter means in between. So there are different type of intermolecular forces in between. So if I have two even molecule, they can still have a little bit of intermolecular forces called dispersion, because that molecule, sometimes as it moves around and the electron flows around, temporarily one side might have more electron than the other. That side will be negative. And the other side, now having less electron, will be positive. So both of these molecules happen to be next to each other. The slightly negative end on one side will be attracted to the slightly positive end on the other side. Okay, and that attraction for molecule that's just temporarily shifting the electron around because of motion is called dispersion force. It's very weak. Okay, and usually if you have a bigger molecule, the shift can be a lot more. So think of it like a tiny little bottle. If you're splashing the water around, it might be heavy on one side for a little bit, but if you have a much bigger water bottle, if you splash it around, the water can get to one side with a lot more volume. So it tends to increase with bigger size molecule. So polar bond, once again, is a bond in between atom. Polar means uneven, okay? That is not distributed equally. So when you have a molecule that have polar bond, it's obviously going to have uneven electron. So pretend I have carbon monoxide with oxygen. Now one of the atoms is going to be a little bit more greedier with the electron. It's going to be slightly more negative, right? And the other one will be slightly more positive. Okay, in this case, the oxygen will be slightly more negative and the carbon will be slightly positive. So when I slice that in half, obviously I have one side that's slightly more negative. If I have another carbon monoxide that comes around, you can see how there would be attraction between the positive and the negative, and that is going to be another type of force we're going to talk about. Okay, so polar covalent bond obviously cause the molecule to be slightly polar in the electrical charge. So if I slice water this way, this side might be slightly more positive and this side might be slightly more negative because the oxygen is more attracted to the electron. So due to that polar bond inside a polar molecule, that means a molecule that's uneven, you will have another type of intermolecular forces called dipole forces. Okay, and this can exist in any molecule that is polar. There's a specific type of intermolecular forces that's unique between polar molecule that contain hydrogen atom, and that's called a hydrogen bond. So earlier we said the water is slightly negative on one side and slightly positive on the other side. And so on this other side now, this is slightly positive and this is slightly negative, and those positive and negative are attracted to each other. So this hydrogen right here is causing it to make this hydrogen bond. So learning to analyze information is quite important. Given these three molecules that contain water, methane, and ammonia, which one of these three molecules do you think have the highest intermolecular forces, specifically hydrogen bond? Because all three of them have hydrogen in them. Now with methane, it's going to be pretty low because it's even. Ammonia, even though it's uneven, is surprisingly even lower based on the data. Now, how do I know that? The stronger the intermolecular forces in between molecule, the higher the amount of energy it takes to separate them. And one way to separate them is to boil them, because as you evaporate them, they are separated. So looking at this, water would have the highest hydrogen bond out of the three because it takes 100 degrees Celsius for it to boil, compared to negative 33.4 and 164 for the other two. Okay, so once again, hydrogen bond can only exist in uneven molecule that are polar, and it has to have hydrogen in it. So with that, here's your three homework question. Which one is polar? Please Google the picture of all four of these molecules, and from that, answer and explain why. Which one of the following molecule can form hydrogen bond? So know the rule for hydrogen bond, so look up the pictures for all four of these and tell me which one will most likely form hydrogen bond. And last but not least, after you read through this section in your book, 12.2, write me a short summary. When I say short, I mean no more than 5 cents, but probably more than 2. Explain what determine a substance state, aka solid, liquid, or gas at a given temperature, and why is it that carbon dioxide, as I breathe it out of my mouth, never want to condense and become a liquid. But water, as I breathe it out of my mouth, if it's cool enough, it will condense and become a liquid.